SwayamPrabha. Digital India. Educated India.
Okay, so as you know, in this week we are focusing on alternatives to plastic. So this is week 7. This would be the last video, last module for this week 7. As you know, every week we have 5 videos of approximately 30 minutes each. So this is the last video, and as the topic for this week is focused on alternatives to plastic, the greener material to plastic. We are so in this last video, and I showed you we went over several examples of alternatives to plastic. So we will kind of discuss a little bit on that in terms of when this plastic alternative plastic will end up in the environment, what are the issues associated with that, and then we will also look at how to quantify something is green. When I say green product or green plastic, better for environment, how to quantify that, and that's discussion will be done in this particular video, and then that will kind of conclude the content for week 7. So let us get started and look at the details. So we were at this particular slide in the last towards the end of last video, we were looking at any of these bioplastic products when they will be disposed into the environment after its use, like traditional plastic as well. So there are different ways you can do it. Essentially it will be part of your municipal solid waste stream. So when you look at these waste product coming out, you will have either if you do not collect it properly, it will be littered. If you collect it and take it to a landfill or a dump site, if you do not collect, then if it gets into the surface water, it may end up finally to the sea. If you do the recycling, you may go for thermal or feedstock recycling. Part of it, if it gets into our body because of the microplastics getting into our water or air or salt, which we talked about earlier in the last week, it can get digested into the body as well. Do nothing in terms of littering, also it can break down in the ground. If it goes for anaerobic digestion, biogas plant, waste to energy plant, you can go for industrial composter or domestic composter. So these two together is basically composting, waste to energy as a incineration, waste to energy from a biological point of view. So this is where these can be end up, and since these are biodegradable, they will get most of it will end up converted to CO2, methane, and those other gaseous products, which can be used as an energy source. Most like a methane can be used as an energy source, but we do not want these gases to be just gone into the environment like that, because these gases also have negative environmental impact. They are the greenhouse gases, so they create problem in terms of the greenhouse gas impact. So major disposal environment we talked about: composting facilities, anaerobic digestion can go to the wastewater treatment plant, it can go to plastic recyclers, landfill, dump sites, marine and fresh environment, or general open environment as litter, which we just talked about. So this is just a kind of again summary of this of the previous slide. So in terms of emerging application areas, it has been used in many different areas. Like it has been used in coated paper, agricultural mulch, shopping bags, food waste film, consumer packaging, landfill cover film, bait bags, fishing line, silage wrap, body bags and coffee liners, nappy backing seat, various sanitary products, cling wrap. So as you saw, like there are several application is there, and based on all the examples that we have seen in this particular week, many of those were already we have these bioplastics coming into those applications. So from all these applications, when it's discarded, it will come to the disposal stream. And there are some modifications are also happening in terms of improving biodegradability of for certain environment. Metallization could provide some barrier properties. They are adding some silicon oxide, carbon dioxide, increased thermal conductivity based on usage. A specialized enzyme can enhance production. Cost effective as petrochemical increase in price. Again, if its petrol price goes up, it sometimes becomes cost effective, but the petrol price goes down, this product are not cost effective. So that's always a problem. So there are always some adverse effect as well. Pollution in waterways due to high BOD, because now you have biodegradable plastics. So if once it's degrade, once from the higher molecular organics, it becomes to lower molecular organics, the BOD numbers goes up. And migration of plastic degradation such as residual pigment, this runoff, leachate from landfill, compost facilities that can contaminate groundwater, surface water. And in terms of biodegradable plastic in the marine environment, if it's 100% biodegradable, if most of it is biodegradable, it is good, but if it's only partially biodegradable or so slow degradation, again that causes trauma and death to marine species as well. So that's not that's that area as well. As I said earlier, since there are very few products out there now which is 100% biodegradable, since there are mostly blended products. So this blended products creates like a half degradability, half non degradable, and they still become an issue for marine environment. So and then some other possible increase in incidence of littering, because when people think that, oh, this is biodegradable, even if I just throw it away on the side of the road, it will get decomposed in few days or but many times that's not true. Even if it's biodegradable, it needs a composting facility, it needs an anaerobic digestion facility to degrade. If you just throw it away, it will take very, very long time to degrade. And then compost, which is has this biodegradable plastic, if they have some contamination, or they have it's blended with traditional plastic with certain pigments and other stuff, which may have some heavy metals, which may have certain organics, and then in that case the soil and crop gets exposed to it from those compost, because of additives and modifiers like coupling agents, plasticizers, fillers, catalyst dyes, pigments, all those things which is there in the plastic, because it is needed for its use. But when you make a compost out of that, and these chemicals are still there, and that gets bioaccumulated in the crop, and then it may lead to adverse health impact as well. So those are issues associated with this biodegradable plastic waste management. So being said that, we wanted to also discuss a little bit, I wanted to have a little bit of discussion in this particular segment on when we say something is green, how do you really quantify that? So because just saying something green is like, okay, this is greener than that, okay, maybe, but how much? What is the numbers? Because as an engineer or a scientist, or in general, like if you go to any legal place as well, they always want some evidence. So what is the evidence that this is green? Yes, your raw materials seems to be better. Based on our past experience, we think that your product should be greener, but how much greener? Because anything new when we do, we have new processes come in. Every process has their own environmental footprint as well. So this whole concept of quantifying the greening of certain product process is what is known as this LCA, life cycle analysis, which is LCA, the full form is life cycle analysis. Now what is this life cycle analysis means? You are looking at from cradle to grave, sometime even from cradle to cradle. Now we will explain that in a minute. Cradle to grave means any product process is from the very beginning. Cradle is jhula in Hindi, that means when a baby is born you put it in a cradle, and grave is when somebody dies you put it in grave, because this concept has come from the Western world where they use grave a lot. So that's where it is coming from. So it's a cradle to grave, from the very beginning to the end. Now that's and you look at the whole environmental impact associated with different things that is happening there. So, when you go for this LCA, you have to look at the material process, you have to find out, okay, what should be your functional, what should be your system boundary, and to do all that there is a ISO methodology, and the sketch that the diagram that you see right above is on this is based on the ISO method for LCA, which is you start with goal and scope definition, you find out what is the goal of doing LCA, what is the scope, you do an inventory analysis to find out what are all the inventory like energy, material in, releases out. So, collect lots and lots of data, and then you do the impact analysis, like after doing the what does it mean, and looking after from impact you kind of make sense out of this LCA, and then you take this for the product improvement, so process improvement and all that. So, we will discuss it little bit, so that even for a bioplastic point of view, whenever we are proposing that, okay, we will replace this traditional plastic with this bioplastic product, now how much real environmental benefit we are getting. So, that is always very important to justify, to quantify. Similarly, like many educational campuses, many cities in India are banning this single use plastic, and they are asking a replacement. So, based on the replacement that is coming into the market, that will decide whether we have really made a significant environmental benefit, or it has more or less just a incremental benefit with some tokenism happening there. So, that is very important. Similar, say for example, I am talking to you sitting in IIT Kharagpur campus. In our campus we have there is a huge drive happen, and right now if you go to the market, you do not see the single use plastic within IIT Kharagpur market. You go outside, still, because Bengal has not banned single use plastic. So, you see those showing up in the grocery shops, or in when you go for buy vegetables or bread and all those, but within the campus single use plastic has been banned. And and there are some alternatives which has come up, some cloth bags have come up, some of those cloth bags also have a very thin layer of plastic inside. So, those needs to be studied, to find out is it really an environmental benefit, which it seems to be, and but what is, how much, what is the quantification of that, because there is a lot of resources also went into making this process, making this thing ban effective. So, that also requires a lot of energy, lot of so whether it is really going to give us the benefit and how much benefit. So, those things can be quantified using this LCA process. So, we will discuss like a little bit in the background of this LCA process. The detailed is there are several YouTube videos. There was a course on life cycle analysis on this NPTEL platform, which is happened 2 years ago. It was rerun again last year, and I hope it will again probably be rerun in the coming future. But this is just a small discussion on that for us to put in perspective for what does it mean. So, in terms of life cycle inventory, as you saw for the ISO methodology, there is an input, there is an output. For every process that you do, for let's say we are making a new bioplastic. So, what are the input goes into making those bioplastic? Here this this stuff is just for example, they are not, don't think that this is what is needed for bioplastic. This is just a illustration example here, and there will be certain emissions coming out. So, what we do is we try to quantify, take all the input, take all the output, and then try to quantify what is the impact coming out of it. And many times for a very small product also, you can have hundreds and hundreds of different elementary flows in terms of input and output, which gets very hard to interpret. Brain cannot consider more than 7 independent parameter at a one time. So, what we do, we try to neglect something which is less than 0.1%. So, that make our life little bit simpler. So, that is done to do that. And with all this data that you set with the inventory, you have for making something, you need lots and lots of data. So, data essentially is coming from a central database these days, and that central database is coming from ecoinvent.org, and that is where its data is coming, and this is from a different sector: agriculture, energy supply, basic chemical, transport, metals, construction, some plastic, paperboard, all those things are there. So, all these data are mostly say for how much what is the input and output that you saw in the previous slide. Say for making 1 kg, 1 kg of like a 1 meter cube of concrete, or this particular cell phone, or even this marker. How much, what is the unit process, what are the different materials here, plastic, some maybe a circuit board, sometimes it is there, some depends if it works as a slide changer, probably it has some sort of relay or something, and so that may have some circuit board. So, all those things we need to look at, all the different parameters, all the different components we need to look at, and how they came and how much it takes to make those as per the unit process, and that unit process data comes from all these different databases which is already has been developed. And these databases, initially when it developed was mostly European based, but now we are getting Indian based databases coming in as well. So, that is also becoming we will have more and more data on Indian based. So, to do the LCA in India, we can use Indian based data, we do not have to rely on European data to do that. So, once you have this elementary flow, which you got all the data, you look at based on the emissions, what are the impact in different categories. Again, do not worry too much about these categories and all that. This is not what we are going to quiz you or ask you questions in the final exam, because this is something which is much broader topic. Just wanted to give you a snapshot. So that you get an idea that whenever we say something greener, we have to really quantify that. If you are really interested to learn more about how this LCA and sustainable engineering and all that, you can look at the YouTube videos on, like if you just go on YouTube and say life cycle analysis with my name, you will find all those NPTEL videos showing up there. So, but these are the different impact categories: human toxicity, respiratory, ionizing by ozone layer, photochemical and all that. And then from the impact categories, you can kind of club them into human health, ecosystem impact, climate change impact, and resource depletion. So, that becomes your kind of damage categories in terms of what will happen with all these emissions. And those emissions are coming up as part of the process of making those bioplastic, for example here, or it could be also part of the raw material which you were used to make those bioplastic, or even the traditional plastic if you want to do a comparison. So, once we have the LCI result, we have these, what you saw was the midpoint, different impact categories, then we have a endpoint, which was also you saw that respiratory level, extent of a species, reduced space. So, this is how we kind of do that environmental mechanism. We try to come up with what is the potential impact to the environment, and then when we cannot really take these kind of information and go to our policy makers, to our leaders and present to them, because it gets too technical. So what we do, we try to come up with some simplification of that, and that simplification requires certain interpretation, so certain weighting, because if you have these three, say, impact categories after from this midpoint categories, now when you try to look at the impact, should we take 1/3, 1/3? Are we going to do 1/3, 1/3 of each one of them, or are we going to put a different, like 40%, maybe 30/30, or 60/20/20? That depends on where you are. Say in your region, if this certain ecosystem or resources depletion is of higher kind of concern, you will use a different weightage. If it's an equal, you can use equal weightage too. But if you think that human health is one of the major concern, that will get the most weightage. So, that's as a practitioner, that's your call, and that's what you come up with in terms of how to do those like interpretation. So, you start with your LCI result, come up get all the emissions number. From emissions number, you come up with this midpoint like a impact categories. Then you take that midpoint impact to come up with the endpoint impact categories, and once you have the endpoint impact categories, you have to use certain weightage factor to put everything together and come up with an interpretation. So, that's what is it's done. So, it's to come up with making some sense out of that. So, again, from if you look at from the beginning, you get all the input and output for the process, you go to the impact categories, and from impact categories you get into the damage categories, and you finally you come up with a single score, and the single score is very similar to what you see for water quality index or air quality index or even for Bombay Stock Exchange index. So, they have a single score, and that score is used to present a certain information. So, because whenever the Sensex is going up, we say that market is doing good. Markets is doing good, that does not mean that each and every company for which it helps, it impacts on Sensex, they are doing good. Some companies are doing good, some companies might be doing bad. Similarly, when Sensex goes down, same observation, some may have gone bad, some may have performed badly, but some may have performed good as well. But the single score helps us to make it easier to understand how the economy is. If you look at stock exchange as one of the indicator for economic performance, that also itself is debatable. We will not go there. We will leave it for our economics professors to do that. But that's the way to look at. Similarly, air quality index. Every time during this winter or during certain time, you get the news that, oh, air quality in this area is getting bad because air quality number has gone above 400, above 450. Now it is in danger level. Now what is this 450, 400? They are combinations of different parameters which has given that number. Similarly, water quality index is there. So similar concept is, you take all these impact categories and put them in a single score, because when you go and talk to a regulator, you say that, okay, I have traditional plastic which has that score of this much in terms of environmental performance. I have this bioplastic which has a number of this much in terms of environmental performance. So bioplastic is better, and it is better by this fraction or this number, by this time or this percentage. So that gives a quantification number. It becomes easy for regulators or leaders and like secretaries, ministers to understand what you are trying to say. You can be an expert on LCA and you come up with a very beautiful graphs, but then it becomes too technical, and then people cannot really understand. So you always, in your presentations, you always have to see who your audience is, and then based on the audience you tailor your presentation, and that's true for all the presentations that you will make in your life. You should always be aware of who the audience are, and you try to tailor it based on the audience. So that's similarly here, when you go for an LCA audience for our ministers or regulators and other places, we have to make sure that it has to be scientifically sound, but not too technical. It should not, people should not get lost on what is happening here. So this whole concept of quantifying green, it's very important concept, and this is the concept of LCA. Some of you may have heard about EIA, which is the environmental impact assessment. So this LCA is kind of a much broader version of EIA. EIA usually we look at localized impact. In LCA we are looking at global impact, and we are trying to capture all the possible impact that is happening from the process, and we go from cradle, from the very beginning to grave, which is to the very end. So that's the whole concept of life cycle analysis. So in terms of life cycle analysis, say in terms of the plastic industries, we can use this. First of all, you need to kind of come up with why you need to do LCA, what is the plan, what is the goal, which application, how you are going to use the results, how it will be reported, who will do the stuff, and you interface with your organization for say plastic manufacturing. And once you can use it for eco design, making a better design. You can come up with a strategy, product declaration. That's also important, as I said earlier, that people are ready to buy greener product if it's really green. So you can make product declaration by doing this LCA kind of exercise, and you show like a summary graph as some sort of flyer or whatever you do in terms of your marketing, where you say that this is actually is greener, because we have done it using we have done the quantification of this particular product as compared to the traditional product. And you can use it for benchmarking, you can use it for life cycle costing. So there are different applications. So once it's done, the LCA experts can work with the designers of products, can work with the product managers, can work with environmental management and safety specialists, and then they look at the whole stuff and come up with a better product design. And the whole process helps us to quantify the real environmental benefit and to come up with a better environmental product. So, in this week when we were trying to talk about the greener alternatives, bio based alternatives to traditional plastic, at some point of time we have to do this kind of exercise and to come up with whether it is really green, whether and how much green the product is. So, that is kind of important thing to do. So, with that we are kind of towards the end of this particular week's material. So, what we saw so far is overall bioplastics is generally more expensive than regular plastic, but there are variety of uses and benefits. If you look at the whole life cycle, this plastics, so that is why the life cycle analysis is important, because traditional plastic may be cheaper, but they have a very huge environmental load, a huge environmental negative impact. And but in this bioplastic may be expensive to start with, but when you look at from a life cycle perspective, since the from the end of life in terms of managing it as a waste is will be much simpler, it may outweigh, we may get a better better result. So, anything we should not just look at in a silos, we should have a look at in a systems perspective. So, where you things in a systems way rather than looking just part by part. So, if you have a unit process, so each and every individual unit is important, but the whole units together, the whole system is very important as well. That is called systems approach. Then the bioplastic will cut down the municipal solid waste, because it mostly biodegradable. So, non biodegradable waste will be reduced, and if we take that and manage it properly, we can reduce the greenhouse gas impact. It's a environmental friendly. How much friendly? You can do LCA and find out, and that is what I would encourage some of you who want to do your projects and other stuff. You should do those kind of projects. You look at all these variety of plastic alternatives that are coming in, and try to get the process information and do a quick life cycle analysis on it. There are several softwares out there which you can download and use it for free for certain days. So, you can use it for student projects, and that is allowed. Then with developing technologies, it's as the technology is developing, the products will improve, and the cost will also get competitive in the market. And finally, we need to quantify the environmental benefit, because just saying something is greener is not good enough. We have to quantify, we have to show how green it is, and that can be done using the tool of LCA, which we just talked about. So, overall at this particular week, our focus was on greener material, better alternative material, and look at what are coming up in the market, what are the different types of material coming in the market, and we also looked at how to really distinguish between greener material versus non-greener material, how to avoid doing the greenwashing. So, that is also very important. So, with that, thank you for this like attending all these videos, and I hope you are enjoying the course. This is the last video for week 7. So, next we will move into week 8, which have a nice transition. We just talked about life cycle analysis and this whole systems perspective. In the next week, we will talk about a concept which is a brand new concept, which is applied in waste management sector in general. That is called the circular economy concept, and we will talk about that, what is circular economy and all that, which will be interesting. And we will also see how the plastic industry and the plastic waste fits into this whole circular economy discussion. So, again, do not forget to take your quiz on time, and you should take all week quiz, although I know you are being allowed to skip few of them, but we will take I think 6 out of best 6 out of 8, if I remember correctly. So, that is but and if you should I think you must have registered for the exam, because that's also important. It's always better to get the certificate, because if you're putting all this effort, and the exam fee is not that too much either. It's just I think 1200 or 1300 rupees. So, with that thank you again, and I'll see you in the next week content, which will be on circular economy and this whole plastics around the circular economy. Thanks. Take care.